Scientific laws and scientific theories are the end products of science, and confusing the two will just make you look bad in front of the scientific community. It's actually quite simple. Let's begin with an example of a scientific law. If you were to drop a pencil right now, assuming you are on Earth, it's probably going to fall down. In fact, if you drop anything on Earth, it'll fall down. You probably already know that this is caused because of gravity. Now, no matter where you go in the world, you drop that pencil, it'll fall down. It's known as Newton's universal law of gravitation. It's just a fancy way of saying that the pencil will fall down wherever you go on Earth. It's pretty simple, and it's something that's naturally observed. Let's quickly break down the name of the law. Newton's universal law of gravitation. Isaac Newton is the guy that originally wrote the law. Universal, that means that the law is accepted and proven everywhere in the universe. Law of gravitation. It's the part that describes the observation that was seen. Now that we have a simple explanation in our mind, let's quickly go over the rules. A statement based on repeated observation that describes some aspect of the world and universe. This is seen in the law of gravity, because wherever you take that pencil in the world, and if you let it go, it'll drop. B, a description of something that is observed. This is just a simple way of saying the above. C, they never provide an explanation. The law of gravity just says the pencil will fall, but it never tells us why, and it will never tell us why. A law never tells us why something happens. D, they usually have an equation with them, but this depends on whether a field may be broken down to mathematical terms. Well, in this case, the law of gravity does have some equations. For example, you can calculate how fast the pencil will fall. However, laws in biology don't really have an aspect of math in it, so they don't really have equations that go with the law. E, scientific laws are universally accepted by scientists, but they're meant to be questioned and challenged. The speed of light was known as the fastest in the universe. It was a law. However, it's questionable now if it's a law. There are many hypothetical situations and different situations when the speed of light might not be the fastest in the world or the universe. Scientists are always trying to find something faster than it. By the way, it's one of Einstein's laws. F, these laws are very rarely ever turned down and disproved. They tend to withstand the test of time, but not all the time. Well, with that being said, I think it's time to move on. A scientific theory. This time, let's begin with an example once again. This time, let's start with the Big Bang Theory, not the TV show, although it's actually a pretty good show. Now, the Big Bang Theory tells us that the world started from something very, very small, like the edge of a pin needle. It just started to expand, and ever since it's been expanding. So, George Lemaitre, I don't know if I'm pronouncing his last name right, but it's spelled Lemaitre. So Google him if you want to know how to pronounce it. Either way, George proposed what he called the hypothesis of primeval atom. And it was a hypothesis. If you don't know what a hypothesis is, it's basically an explanation of something. We'll get into that when we cover the scientific method. Now either way, it started as something that he put on paper. After years of research, his hypothesis, his idea, his research, and research from other scientists, it began to prove the theory. The research is quite interesting, but we won't cover that right here. But back to the subject, there was so much support that it became universally accepted. It was an explanation to how the universe began. Now let's go over these rules quickly. A scientific law is something that explains scientific observation, or in another way, it tries to explain the scientific laws. Answering why gravity pulls things down to the Earth would be a theory. Well, it really doesn't start as a theory, which brings us to B. It starts as a hypothesis, just like how the Big Bang Theory started. Now C, If evidence accumulates and it becomes widely accepted, it ends up as a theory. That's what happened with the Big Bang Theory. At first, people saw the hypothesis and were like, this dude is crazy. Once the evidence popped by, they were like, George is probably onto something. It stays a theory until evidence disproves it. It's occurred many times, and theories being disproved are still occurring now. Overall, it's just an accepted hypothesis. I think it's about time we wrap this up. In conclusion, a scientific law is a description of something that's observed over and over again in nature. It's something that will occur, and from that a question arises. This question is, why does something occur? That's what a theory proceeds to explain. So, a scientific law is a fact. Then, what's the difference between a fact and a scientific theory? Nothing really. They're both facts.